Hi guys, Miss Monserrati here, and it's going to be Friday. It's Thursday, I'm recording this, but we are going to do our lesson asynchronous. Synchronous is when we're all together, live, doing it together. Asynchronous is when I record it, and you can watch it later on your own. Alright, so we're going to skip this chapter, or this lesson, but I am going to kind of look at it a little bit so that we can do check my progress. Alright, so scaling is the process of resizing a number when you multiply by a fraction that is greater or less than 1. So if I want to multiply the number 2 by 3 fractions greater than 1, I'm going to resize them. I'm going to take 2 and I'm going to do it by 3 numbers that are greater than 1. Right? 1 1/5 is bigger than 1, 1 1/2 is bigger than 1, and 1 3/4 is bigger than 1. So first I'm going to do my 2 times 1 1/5. So we have been multiplying, we were doing mixed numbers by another fraction, but now I'm doing a mixed number times a fraction. So I can just do this. I'm going to times my number, my whole number times my whole number, and I'm going to times my whole number times my fraction, which is all we're really doing anyway. So I'm going to do 2 times the 1 is 2, and I'm going to do my 2 times my 1/5. Right? And we remember that 2 can be made into a fraction, and then I'm going to have this will be 2/5, because 2 times 1 is 2, and 1 times 5 is 5. Alright, my next problem, I'm going to do the same thing. I'm going to take my 2 times my 1 and my 2 times my 1/2. So 2 times 1, right, is 2, but they only gave me one box here, right, so I'm not going to have a fraction, is my 2, plus I need to add my 2 times the 1/2. Right, so I can't forget my 2. I'm going to keep bringing it with me. I'll do this problem up here. So I'm going to have my 2 still, plus, right, I already did 2 times 1, so now I need to add it to my 2 and 1/2, to my 2 times 1/2. I'll turn this into a fraction, right? 2 times 1 is 2, and 1 times 2 is 2. So you can see, right, this is going to be 1, and 2 plus 1 is 3. My answer is 3. Alright, now I'm going to do my 2 times 1 and 2 3/4. So hopefully, right, you could see that this is going to be bigger than 1. So I'm going to have to add my numbers together. So I'm going to have my 2 times my 1 plus my 2 times the 3/4. Oops. Alright, so I'll do my 2 times my 1. Right, I do my operations in my parentheses first, but I would do my multiplication before I'd add anyway. But so I do 2 times 1 is 2, plus 2 times 3/4. I'm going to change this into a fraction, 2 over 1. So now I'm going to have 2 times 3 over 1 times 4. So now I would have 2 and 6/4, right? But 6/4, we're going to change that. It's an improper fraction. I'll do it this way. 6/4 is going to be equal to 4/4 plus 2/4. Right, so this is going to be 1 and 2/4, right? I'm going to divide by 2 and divide by 2, and I'm going to get 1/2. So this is equal to 2 plus 1 1/2. So my 2 plus my 1 is going to give me 3 and 1/2. Final answer. And they want me to plot these on my, now I need to plot them on the number line. Then I'm going to plot my 2 on the number line and then plot the products on the number line. So here's my 2. They already plotted it for me. So I'm going to do my 2 and 2/5. Right, so I'm going to break this up into 1, 2, 3, 4, and I'm going to do 1, 2/5. And so when I plot a number, I label it, tell them what I plotted. I also need to plot my 3. I'll write it here just for fun. It's already there on the number line, right? 3. And now I need 3.5. So I'm going to break this line in half. And here's going to be my 3 and 1/2. Oops, I forgot to plot it. Now I need to compare the products. Circle whether the products are greater than, less than, or equal to 2. Right? The products, my only number that was equal to 2 is the number I was multiplying by. So all of my products are greater than 2. Multiply a number by a fraction greater than 1 results in a product that is blank than the number. It is going to be bigger, it's going to be greater. Alright, I just did this for the scaling. Right, scaling is the process of resizing a number when you multiply a fraction that is greater than or less than 1. So it's just making my number bigger, right? If my number is greater than or less is greater than. Okay, so I need to keep going before I can really explain this. But right here we multiplied a number times a fraction that was greater than 1. Right, so scaling, it's bigger now, right? These are bigger numbers than the number I multiplied it by, because the number I multiplied it by were bigger than 1, right? I had 1 and 1/5, 1 and 1/2, 1 and 3/4. So my 2, when I multiplied, I had more. Greater, right? It's bigger than. All right. Now I'm going to multiply the number 2 by 3 fractions that are less than 1. So here I'm going to multiply by 2 and 1/4. Sorry, I'm going to multiply by 1/4, 1/2, and 5/8, which are all smaller than 1. Right? If I had 1, a fourth of 1 is smaller than 1. If I had the same 1, half of it is still less than 1. And if I have my same 1, right, and I did 5/8, 1, 2, 3, 4, 5/8, it's still less than 1, still smaller than 1. So I'm going to take my number 2, and we'll see what our answer is. All right, so 2 times 1/4, I'm going to turn my 2 into a fraction, and I'm going to multiply straight across. So I'm going to have 2 times 1 is 2, and 4 times 1 is 4. I do need to reduce this, huh? Divided by 2, divided by 2, 2 divided by 2 is 1, 4 divided by 2, I need to simplify it, is 1/2. Alright, so now I'm going to do 2 times 1/2. Right, hopefully you see I'll have 2 over 2, which is equal to 1. And now I'm going to do 2 times 5/8. And I'm going to say 2 times 5, I'll do it over here, is 10. And 8 times 1 is 8. Right, this is an improper fraction. We're not going to leave it like that. Instead, I'm going to do 8/8 plus 2/8, right, which would be 10/8, is going to give me 1. And 2/8, I will not leave 2/8. I'll divide by 2, divide by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. My final answer is 1 and 1/4. So I'm going to plot them on my number line. There's my 2. I have to plot my 1/2. Right, here's my 0, here's my 1. So here, I'm going to plot it, is my 1/2. My 1, I'm going to plot it. I will label it even though it's already on the number line labeled there. and my 1 and 1/4. So here's 1. I need to do 1 and 1/4. So I'm going to break my line up into 4 pieces. So I drew 3. I separated it 3 times. Right now I have 1 piece, 2 piece, 3 piece, 4 pieces. And here is going to be my 1 and 1/4. So I'm going to compare the products, right? The products are the answer to a multiplication problem, and circle whether the products are greater than, less than, or equal to 2. Right, here's my 2. All the products I plotted are less than 2. So multiplying a number by a fraction less than 1 results in a product that is less than the number. Alright, so all I'm saying with my scaling is if I multiply a number times a fraction less than 1, it's going to scale, it's going to be smaller. If I multiply it by a number that's greater than 1, it's going to be bigger. And I'm using this. Scaling is the process of resizing a number when you multiply by a fraction that is greater than or less than 1. It's either going to get bigger or smaller. Alright, so our vocabulary check. Fill in the blank with the correct term or number to complete the sentence. There's only one. Scaling is the process of blank a number when you multiply by a fraction that is greater than or less than 1. Right? I'm resizing it. I'm changing the size of it. I'm either going to make it smaller if it's smaller than 1, bigger, or smaller if it's smaller than 1, and bigger if it's bigger than 1. I think I said it right the first time. Alright, so shade the models to find each product. Write in simplest form. So I'm going to shade my models. I'm going to look over here. I'm going to label them 2/5 and 1/2. Right, here's where my 1/2 is going to go. And 2/5. Right, out of my 5, my 2/5 is going to be right here. So I'm going to shade. Because these are fractions, right, I can count my whole total. Before I had whole numbers. These are just fractions, so I can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I had 2 out of 10. And I can divide by 2, divide by 2. I'm going to have 1/5. And my next problem is 3/4. So, right, this is a little different than what we did in class on Thursday today. Right, I had whole numbers. I was multiplying a whole number times a fraction. These are still fractions, but I'm going to make my fraction smaller, right? I did 1, 2, 3, 4, and then I will put these together to make 5, right? So I have 5. I colored one of my 2 blocks there. That's why I have 1/5. All right, my next problem I have 3/4. I'll do that down here. Here's my 3/4. And I'm going to multiply that times 3/5. I'm going to color it in. I'm going to count all together. I know I have, right, 1, 2, 3, sorry, I'm going to do it this way. 1, 2, 3, 4, 5, because that's easier, right? 5, 10, 15, 20. Out of my 20 squares, I colored 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't divide them up equally and still have one whole group, right? I could divide them up into 5s and 4s, but then I wouldn't have 9, because 9 can only be broken up into 9 or 3s. So it's just going to stay like that, 9/20. right? I could have just done this way too instead of using my models for both of these, right? I could have said 2 times 1 is 2, 5 times 2 is 10, and reduced it. Divide by 2, divide by 2. 3 times 3 is 9, 4 times 5 is 20. All right, we're going to keep going. I'm going to just multiply straight across. I'm going to multiply and then write in simplest form. 1 times 4 is 4, and 9 times 2 is 18. Both of these are divisible by 2. 4 divided by 2 is 2. 18 divided by 2 is 9. Es lo más simple. Okay, my next number. I'm going to multiply my numerators and my denominators. 4 times 5 is 20, and 5 times 6 is 30. I can divide both of those by 10. Divide by 10, divide by 10. 20 divided by 10 is 2. 30 divided by 10 is 3. All right, my next one, right? Uh-oh. Right, I cannot multiply straight across. I need to turn this into an improper fraction first. I'm going to multiply the numerator times my denominator times my whole number and add my numerator to it. I'm going to turn my times into a star. Remember, you can always write times as a star. You could write it as a dot. You could also write it as parentheses. Put numbers in parentheses. Right, I could have 5 times 9, or I could have 5 times 9, or I could do it the old-fashioned way, 5 times 9. But my times can be a star, it doesn't matter. Alright, so I'm going to take 4 times 3 plus 2. I'll write it right here. So 4 times 3 is 12, plus 2 is 14. And it's still going to be over 3. Alright, so now I can multiply. I'll write my answer up here. 14 times 1 is 14, so I don't have to write it twice. 5 times 3 is 15. They do not have anything in common to divide them up by. Right, this could be divided by 5 or 3. This could be divided by 7 or 2. They don't have anything in common. Alright, now I have 2 mixed. I'm going to turn them into improper fractions. I'll write them down here below, and then I will multiply them, and I'll write my answer up here. So this denominator, right, is 8. This denominator is 6. It does not ever change. The denominator will stay the same, but I will take my 7 times 8, right? Hopefully you remember my lovely trick. Right, 5, 6, 7, 8. So 7 times 8 is 56. Oops, and then I have to add my 1. Can't forget that part. I got so excited I got my multiplication, I forgot to add my 1. 6 times 2 is 12, plus 5 is 17. Now I can multiply straight across, right? I said I was going to write it right here. 8 times 6, we'll do that first. That's my easy one, right? 48. 57 times 17 is a little bit tricky. I'll do it up here. It does not matter which number I put on top. 7 times 7 is 49. I carry my 4. 7 times 5 is 35. Plus 4 is 39. Now I'm going to multiply. I multiply both the top digits times the number in the ones place. Now I need to multiply both my top digits times the number in the tens place. I am going to put a 0 here to hold my place so I don't put a number accidentally in the ones place, because now I'm multiplying by the tens place. 7 times 1 is 7. 5 times 1 is 5. I'm going to add these numbers together. 9 plus 0 is 9. 9 plus 7 is 16. Carry my 1. 5 plus 3 is 8, plus 1 is 9. So I'm going to have 969. You guys are like, wow, right? That's a big number. But we can still do it. Alright, it's an improper fraction. We won't leave it like that. I'm going to do my work down here. I'm going to have 969 divided by 48. So, right, I could say, oh, is it going to go one time? We could try it. How many 48s are there in 9? None. How many are there in 96? Maybe 1. Maybe 2. Let's try 1. 1 times 8 is 8. Right? You know I'm doing it wrong when you see me writing in pencil. 1 times 4 is 4. I subtract. I will borrow from my 9 and turn it into an 8. 16 take away 8 is 8. 8 take away 4 is 4. Hopefully you see there. There was one more 48 in there. Right? So this is when I'm like, no, it wasn't 1. It should have been 2. So 2 times 8 is 16. Carry my 1. 2 times 4 is 8 plus 1 is 9. Ooh, I subtract, I got 0, nothing. I'm going to bring down my next number. It's a 9. Can 48 go into 9? No. It can go in there 0 times. 0 times 48 is 0. Subtract, I have 9. Right, normally I'd put my remainder of 9, but I'm not. I'm going to make it a fraction. 9 over 48. Alright, so do these have anything in common? Right, 9 and 48. I try to think about if it has anything in common. Right, I know my 9s. I know 9 times 5 is 45. So it's not going to be that, right? How about a 3? Can 48 go into 3? We could try it. Let's see. 3 go into 4? Yeah. 1 time. 1 times 3 is 3. I will subtract. Take a 1. Bring down my next number. It's an 8. Can 3 go into 18? Yes. 6 times. 6 times 3 is 18. I would subtract to get 0. 16. So this is going to be equal to 20. I'm going to divide by 3, divide by 3. 9 divided by 3 is 3. 48 divided by 3, I just did over here. So my final answer is 20 and 3/16. Pause it if you need to. Alright, without multiplying, circle whether each product is greater than, less than, or equal to the whole number. Right, so 4 and 1/8, is that going to be greater than, less than, or equal to 7? Right, I already know it's multiplying times a 7. It's a number greater than 1. So because I'm multiplying my whole number times a number bigger than 1, my answer will also be bigger than 1 because of my scaling, right? It's going to make it bigger. How about 3/5 times 1? Well, hopefully you remember your identity property. It's not greater or less than. It's going to be the same. 3/5 times 1, anything times 1 is the same. All right. Tom spent 1/6 of the day working in the flower bed. Tom spent 2/3 of that time adding mulch to the flower bed. What fraction of the day did Tom spend adding mulch? So mulch is when I plant flowers, I call it a flower bed right there where the flowers are sleeping in the flower bed. And so mulch is a kind of dirt and stuff, I want to say wood mixed up to help the plants grow better. So 1/6 times 2/3. People buy mulch to make their plants grow better. Alright, so I'm just going to multiply straight across. 2 times 1 is 2. 6 times 3 is 18. I'm going to divide. 2 divided by 2 is 1. 18 divided by 2 is 9. 1/9 of the day. I keep telling you guys I'm going to write in cursive and then I don't. That's my cursive printing. All right, right. I know he spent a fraction of his day gardening, and a part of that fraction he spent doing the mulch. So I multiply it. It seems like we divide it, right? But we don't. I want to find 2/3 of this time, so I'm going to multiply it. All right, here's Nick. He spent 1 3/4 of an hours doing homework. Of that, 2/3 was spent on on a social studies project. How many hours did Nick spend working on the project? So 1 3/4 of the hour. I'm going to figure out what 2/3 of that would be. I'm going to multiply it. Right, I can't multiply this because it's a mixed. I need to turn it into an improper fraction. I'm going to say 4 times 1 is 4 plus 3 is 7. My denominator will still be a 4. My other fraction is still 2/3. 7 times 2, 14. I don't know why I put a plus there again, so I'm going to turn it into a star again. Right, I'm multiplying. 4 times 3 is 12. This is an improper fraction. They gave me a nice little spot over here to do my work. So I'm going to take my 14/12 and I'm going to figure out 12/12. I could write 12/12 plus 2/12 would be my 14/12. I'm doing backwards, figuring it out by going backwards. So 12/12 is equal to 1. 2/12 I would divide by 2 and divide by 2. So this is going to be equal to 1. 2 divided by 2 is 1. 12 divided by 2 is 6. So my final answer is 1 1/6 hours, right? We're measuring hours. And here is Anita. She grew a garden with 3/4 of the area for vegetables. In the vegetable section, 1/6 of the area is carrots. What fraction of the total garden is carrots? So her garden is 3/4 vegetables times the 1/6 of it is carrots. I'm going to multiply straight across. 3 times 1 is 3. 4 times 6 is 24. Hopefully you see that, right? Both of those numbers are divisible by 3. 3 can be divided by 3, and 24 can be divided by 3. Right? If I wasn't sure if it was divisible by 3, right, because I know the only number this can be divided by is 3. 3 can only be divided by 3, or 1, and if I divide by 1, I'd have 3. Right? If I can't remember, I can go look at my chart. 3's, oh, there it is, 8. Right? 8 times 3 is 24. So 3 divided by 3 is 1. 24 divided by 3 is 8, because 8 times 3 is 24. 1/8 of, let's do cursive, the garden. I should have done it of cursive. This is a of cursive. Right, I could give my little F a little tail coming out if I want to. Alright, here is Mr. Taylor collected apples on Friday. On Saturday, he collected 2/3 of the amount collected on Friday. How many bushels of apples did Mr. Taylor collect on Saturday? Alright, so if he collected this much on Friday, he collected this 2/3 of this amount that he collected on Friday. So I want to know how many he collected on Saturday. So it tells me right here how much he collected on Friday. I know on Saturday he collected 2/3 of that. So I'm going to do my 3 and 2/3, the Friday amount, and multiply that times the 2/3 he collected 2/3 of this amount. So I want to see what that amount is that he collected. So I can't do this, right? I need to turn this into an improper fraction. My 2/3 will stay the same. My 3 and 2/3 though, right? 3 times 3 is 9, plus 2 is 11, thirds. Right, the other way I could do this 3 2/3, if that is confusing to you, right, I could just do this. 3 times 2/3. Sorry, I wouldn't do 3 times 2/3. I'd say 3 plus 2/3. 3 plus 2/3. Right, I can't add this 3 to that. I can turn this into a fraction, right? Now I can add them. 3/1 is my fraction, but sorry, it should be a plus. Now it looks like a division because I was making the stars, huh? Let's turn it into a beautiful plus sign. Plus. Alright, so I want to add these together, right? When I add fractions, I have to have the same denominator. So I could turn a 1 into a 3. Easy, cinchy, right? 3. So I would take my 3 times 1, so I'd have 3, 3, 3. Whatever I do to the bottom, I need to do the top. 3 times 3 is 9. Now, right, that's what I did. 3 times 3 is 9 plus my 2. 3 times 3 is 9 plus my 2. So that's all I'm doing, right? This is the longer way to do it. Probably it is the longer way. So I have 11/3 times 2/3. Now I can do my math. 3 times 3 is 9. 11 times 2 is 22. But 22 nights I cannot leave like that. I could do this way, right? I could figure out how many, right? I would figure out how many times I could take 9. I'd have 9/9 definitely, right? I could have at least 2 9/9s, and then I'd have some left over. So there's a few different ways to do this. I'm going to do it this way. 22, and I'm going to divide it up by 9. I'm just going to do my division problem, right? All a fraction is a division problem. It means 22 divided by 9. So can 9 go into 2? No. Can 9 go into 22? Yes, right? If you're like, oh, I don't know how many times 9 can go into 22, get out your multiplication table. Look at 9. 1 time would, or 2 times would be 18. 3 times is 27. Too big, right? I only need 22. So I'm going to say 2 times. So 9 times 2 is 18. We will subtract. I cannot take 8 away from 2, so I'm going to borrow from there and turn this into 12. 12 take away 8 is 4. So now I'm going to have my 4 as my numerator and my 9 as my denominator. Sorry, this 9 is in my problem over here. 2 4/9, 2 4/9, bushels, bushels. Happy spring break, guys. Send me your work. Take a picture of it and send it to me. Thank you.